Hello everyone. In this video we will learn about the combination of solids. Combination of solids means if we combine or attach two different objects, two different solids with one other, and that is by joining their one of the face. Then how to find out their total surface area and volume we will be learning in this particular video. See, first case we are taking here is two cubes. If we are joining them with one face, like these two are the cubes, you can see. These two cubes, if with one face of each and this we are joining together like this. And we want to find out the total surface area of this solid. Now this is no more a cube, this becomes a cuboid. And then we can find out the total surface area of this by applying the formula of finding the total surface area of a cuboid, and the volume will be the sum of the two cubes, or we can find out that of the cuboid which is formed here. We will find this cuboid, the length of this will be equal to twice of the edge of the cube, breadth and the height will be same as that of the cube. So we are finding here in this particular figure two cubes have been joined, and then the total surface area in this case will be the total surface area of cuboid. The volume also we can find out this by finding the volume of cuboid. The only thing we are finding, the length of this will be 2a, breadth will be a, and the height also will be a. This is the first case we have taken. The second case we are taking, if we combine one of the cylinder with a cone, we can also say that a cylinder surmounted by a cone. Then the base of the cone and the top of the cylinder will be combined inside. There will not be any more surfaces of this. You can see here the demonstration. We can understand this by a model. This is a cylinder. You are finding this is having two faces, the base and the top, and here this is the cone. In this cone also we have, this is the curved surface and this is the base of this. If we surmount this by this is, here we are joining one of the cylinder and the cone. You are finding this base of this and the top of this are no more surfaces of this particular solid which is formed now. It means when we want to find out the total surface area of this, we will add the curved surface area of the cone, the curved surface area of the cylinder and the base of the cylinder only. Not to confuse that we will add the total surface area of cone and the total surface area of the cylinder. So here in the second case we are finding the total surface area will be equal to curved surface area of cone plus curved surface area of cylinder plus area of base. The volume will be sum of the volumes of both because that is a space occupied. This is the second case. In the third case, what we find, if we add or attach one of the hemisphere and a cone, then what will happen? Let's understand this also by a demonstration, by a model. See, this is a cone. This is a hemisphere. This is the base of the hemisphere, this is the base of the cone. If we join them, attach them together, see here, the base of the cone and the base of the hemisphere, they are inside now, there are no more faces of this, there are no more surface of this. It means to find out the total surface area in such case, we will add the curved surface area of the cone and the curved surface area of the hemisphere. So we can see this here now. In this case, the third case, total surface area will be equal to curved surface area of cone plus curved surface area of hemisphere. The volume will be the sum of the volumes of cone and the hemisphere. The next case we can take fourth case. Here to understand, this is a cylinder surmounted by a hemisphere. Here also we will find the same thing, the base of the hemisphere and the top of the cylinder, they are attached together, they are joined together, so they are no more surfaces of this. You can see here with the model again, this is a cylinder and this is a hemisphere. You are finding this is the base of the hemisphere, this is the top of the cylinder. If we join it together like this, you are finding this is the solid made. And in this, these two faces are joined together, so there are no more surfaces of this. It means to find out the total surface area of this, we will add the curved surface area of hemisphere, curved surface area of cylinder and the base of the cylinder. So here in this case, we write this, the total surface area in this case will be curved surface area of hemisphere plus curved surface area of cylinder plus area of base. To find the volume in all the cases, we find that the volume of each will be equal to the sum of the volumes of the solids which have been attached together. So we can write the volume will be equal to sum of volumes of the solids which have been joined or attached. That we can write like V1 plus V2 plus so on. If there are more than 2, we can write V3 and V4 and all. Now suppose some of the solid part has been scooped out or cut out from a particular solid. Then how to find out its total surface area and volume? Let's understand that also. Suppose we have a cylinder here of height capital H and the radius R, and a conical part has been cut out of it or scooped out of it, and the height of this conical part is suppose small h and the radius is same as R. To find out the total surface area in this case, we will find out the curved surface area of cylinder plus area of base plus the curved surface area of the cone. Why? Because inside it, of course, it has been scooped out, but even then it becomes a surface. So this will be plus curved surface area of cone. That we have to remember. Even if it is scooped out, this is a surface. This is forming a surface inside. So we will find out the total surface area by adding the curved surface area of this plus the curved surface area of this and plus the area of base. And the volume of the material of which it is made, we can see that this much portion has been taken out. It means this much volume of the material of which it is made is cut out now. So we can find out the volume of the material, that will be volume of cylinder minus volume of cone. Now suppose from a solid cylinder a hemispherical part is cut out or scooped out. Then the same way we will find out the total surface area of this by adding the curved surface area of cylinder plus the area of the base and the curved surface area of the hemispherical part. This will be a surface. So we find the total surface area will be curved surface area of cylinder plus curved surface area of hemisphere plus area of base. To find the volume, again the same way, the volume of this material of which it is made will be equal to the volume of cylinder minus volume of hemisphere. In case this hemispherical part has been cut out from both the sides, then this will be minus volume of two hemispheres. And here in the case of total surface area, that will be curved surface area of cylinder plus curved surface area of two hemispheres on both the sides. This is the only thing we have to understand when we are combining two of the solids or scooping out some of the solid part from one of the solid. To understand the concept more clearly, let's discuss some of the examples. And the first example here is the interior of a building is in the form of a cylinder of diameter 4 meter and height 4.6 meter, surmounted by a cone whose vertical height is 3 meter. Find the volume of the building. We draw a diagram of it. The lower part of the building is a cylinder whose diameter is 4 meter and the height is 4.6 meter. It is surmounted by a cone whose height is 3 meter, and since it is surmounted by this, the diameter of both have to be same. So for the solution of such problem, what we do, we write the diameter equal to 4 meter. It means the radius R is 4 by 2, that is 2 meters. Height of cylinder, height of cylindrical part or cylinder, that is H, suppose 4.6 meters, and the height of conical part, or we say cone, that is suppose H1, that is equal to 3 meters. To find the volume of this building, what we have to do, as we learned just now, we have to add the volumes of both. So we write therefore volume of building is equal to V1 plus V2, that is volume of the cylinder plus volume of cone. If we want, we can write here volume of cylinder plus volume of cone. We know the volume of cylinder is pi r square h, and the volume of the cone is 1 by 3 pi r square h1 here, because height is h1. If we take pi r square common on both, this will be h plus 1 by 3 h1 or not. Substituting the value, we get 22 by 7 into 2 square into h, that is 4.6, plus 1 by 3 into 3, because the height of cone is 3. This 3 cancels this 3. 7 cancels this 0.8 times 7 8 is 56. So it comes as 22 into 4, 88 into 0.8, which is equal to 8 8 is 64, 6, 64, 70. So it comes as 70.4 meter cube. This is the volume of the building. The second problem we have, a model is in the shape of a cylinder with two equal cones attached to its ends. The diameter of the model is 8 centimeter and length is 15 centimeter. Each cone has height 3 centimeter, then find its total surface area. See, we are drawing the diagram for it. This is a cylindrical part and the cones attached to both the ends of it. The total height has been given as 15 centimeter and the diameter is given as 8 centimeter. For the solution, we write here diameter is equal to 8 centimeter. It means the radius is 8 by 2, that is 4 centimeter. The total height of model is given as 15 centimeter. Height of each cone is equal to 3 centimeter. So can we find out the height of the cylindrical part? So we can write therefore height of cylindrical part is equal to 15 minus 2 into 3. 3 centimeter on this side, 3 centimeter on this side. This is 15 minus 6 equal to 9 centimeter. Now Now we know that to find out the surface area of cone we need L, the slant height. So we can write slant height of conical part, or we can say cone. The formula is root of h square plus r square. Substituting the value we get here, root of height is 3 centimeter. Radius is 4 centimeters, so this is 4 square, and we get it as root of 9 plus 16, which is root of 25, or we can say 5 centimeter. Now after finding these all, we can write this height of the conical part, suppose h1, and the height of the cylindrical part, suppose h. Then the total surface area of this model will be curved surface area of the cylinder plus curved surface area of this cone plus curved surface area of this cone. And since both the cones are equal, we can write the twice of curved surface area of one cone. So we write here, therefore, total surface area is equal to curved surface area of cylinder plus 2 into curved surface area of cone. We know the formula of curved surface area of cylinder, that is 2 pi r h, and the curved surface area of cone is pi r l, so we can write this as 2 into pi into r into l. If we take 2 pi r common, will it be h plus l? Substituting the values, we get 2 into 22 by 7 into r. R is 4 into h, that is the height of the cylindrical part, that is 9, plus L is 5. Simplifying this, we get 2 into 22 by 7 into 4 into 14. 7 cancels this twice. So we get here 22 into 2 is 44 and 4 to the 8. This comes as 8 4 ja 32, 32 and 3 35. So this comes as 352 centimeter square, which is the total surface area of this model. The next problem is, an ice cream cone is in the shape of a cone surmounted by a hemisphere. If the radius and the height of the conical part are 1 centimeter each, then find the volume of the ice cream. We are drawing the diagram of the ice cream cone here. This is the cone whose height and the radius are 1 centimeter each. Obviously, the radius of this hemispherical part also will be 1 centimeter. It means the radius is equal to 1 centimeter and height is also 1 centimeter. Then to find out the volume of the ice cream, we will find the sum of the volume of the cone and that of the hemisphere. So we can write here, therefore, volume of ice cream is equal to volume of cone plus volume of hemisphere. Volume of cone we know is 1 by 3 pi r square h. Volume of hemisphere we know is 2 by 3 pi r cube. Are we getting 1 by 3 pi r square common in this? If we take that common, it will be here h plus 2 into r or not. Now substitute the values. We are getting 1 by 3 into pi into r square means 1 square. Height h is 1. Plus 2 into radius is 1. It comes as 1 by 3 pi into 1 plus 2. This is equal to 1 by 3 into pi into 3. 3 cancels this 3. So it comes as pi centimeter cube. It means the volume of the ice cream is pi centimeter cube. That is the answer. The next problem is, a wooden article was made by scooping out a hemisphere from each end of a cylinder. If the height of the cylinder is 10 centimeter in total and its base radius is 3.5 centimeter, then find the volume of the wood. So we draw the diagram for this. This is suppose a cylindrical part, scooped out the hemispherical part from both the ends, and since the radius of the cylinder is 3.5 centimeter, the radius of the hemispherical parts are also to be 3.5 centimeter. The total height of the cylinder is 10 centimeter. Now once this particular part is scoped out, we can understand that this much part of the wood has been taken out from it. It means the volume of the remaining wood in this will be equal to the volume of the cylinder minus the volume of these two parts. Let's find the solution. In solution we write the radius r is 3.5 centimeter and height h has been given as 10 centimeter. Therefore, volume of wood is equal to volume of cylinder minus 2 into volume of hemisphere. We know the volume of cylinder is pi r square h and the volume of one of the hemisphere is 2 by 3 pi r cube. Are we getting pi r square common here? So we will be left with here h minus 4 by 3 into r. Substituting the values we get 22 by 7 into r. R is 3.5, 3.5 into 3.5 into h, h is 10 minus 4 by 3 into r, that is 3.5. Simplifying this, what we get, 7 cancels this 0.5 times. 22 into 0.5 is 11 into 3.5 into, here if we take 3 is the LCM, this will be 30 minus 3.5 into 4 is 14. And we find here 11 5 is 55, 11 3 is 30 and 5 38.5 into 30 minus 14 is 16 upon 3. Multiplying this, we get here 616 upon 3 centimeter cube. This is the volume of the wood. In the next video, we will be learning about the conversion of the solids. It means if one of the solids is melted and recast into some of the smaller solids, how many solids can be formed? Or if many of the solids or two or more solids are converted into a single solid, then what will be the changes in its dimension? That all we will be learning in the next video. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.